we're going to add a row that says information. And the thing that goes in that row is going to be how to get to moles. So we're going to add an I row here in just a moment. We're going to produce some nitrogen gas using this reaction right here. My problem is to figure out how many grams of nitrogen I can make from 18.1 grams of NH3 and 90.4 grams CuO. Now we're going to write a big red reminder. This is a clubhouse. No grams allowed. So I cannot take that 18.1 grams and that 90.4 grams and just plunk them into my BCA table. It is a clubhouse. No grams allowed in the club. And that's where the information row comes in. The information row is going to help us get out of grams. So using your periodic table, 1 mole of NH3. Oh, gee, I had that one before. 17.031. So 1 mole of NH3 is 17.031 grams. I want you to do the rest of the information row. Use your periodic table and calculate how much 1 mole of each one of those weighs. 1 mole equals 1 mole equals 1 mole. So the BCA table is a very exclusive club where no grams are allowed. But now I have ways to get things into moles. So I'm going to have to take my grams of NH3 and convert it into moles, and my grams of CuO and convert that into moles. And that's what I'm going to do down here in this space that I left for my solve step. I have 18.1 grams of NH3. And if I look up in the I section of my BCA table, 1 mole of NH3 weighs 17.031 grams. Now, you will notice that I'm starting to get fairly meticulous in my labeling. I have 5 compounds to worry about, 5 different molar masses. You'll notice that I'm starting to label my grams with grams of what and my moles with moles of what, so that I know I've got the right compound in the right place. Stoichiometry definitely favors the meticulously organized human being. Three significant figures, 5 significant figures, keep 3 in my answer. 1.06 moles NH3. Aha, I can put that in. I'm going to do the same thing to my 90.04 or 90.4. That's grams of CuO. And now we're back on familiar territory. You know what to do now. We've got 1.06, we've got 1.14, we've got a BCA table. We're into moles, which is a way to count particles. We're out of grams. So we just do it. We manage our BCA table. So I'm going to try to use up all this one. That means I'm going to have to spend 3/2 as much. I see if it's going to work. It's not going to work. So I'm going to spend 1.14 moles. I'm going to spend 2/3 of 1.14 moles. Yep, I can afford that. And then lastly, after I've got that BCA table filled in, I have to look at the question that was asked. The question was, how many grams of nitrogen am I going to produce? So that's this box right here. But I'm asked the question in terms of grams. But up in the information step, I have a way to get back to grams. .6 grams of N2. Okay, I'd like you to push your desks back where you can talk to one another. And as a team, try to work your way through the your turn. If you're at home, I'm going to leave you out of your breakout rooms, have you kind of work on your own here, because periodically I'm going to fill in some steps here for people to look at. So if people are stuck, they can pop their heads up. So I'm going to keep you out of your breakout rooms for now. Okay, and I'm going to work along at a somewhat slow rate on mine. So if you and your team get stuck, you can pop your head up and see if I've made it as far as you've made it yet. But I'm going to intentionally go real slow so that you have to kind of think your way through a little bit on your own. So working with your team, see what you can do here. Careful with that one oxygen idea over there, guys. Remember, oxygen's diatomic.
I think it's actually SD that's because I just made 0. Oh wait, I put it in there.
Yeah.
I think SD runs on this, but I think you do have like 3 or 4.
Because if you need 4/3 of oxygen. You need 3/4.
two. So, using one roll, so for irons, left over. So you take away 0.272.
And how many?
So nothing, so it'd be four, it'd be for iron, it'd be -4.
That'd be -3.
Because the mold.
It's
So it's
four
not
iron.
anything to react with the top of the rock, what you need is the excess goes
So you can like, this is not really on the bottom. I'll have to eliminate one of them for. So I have to go to it. Then when I put four to that, did that for, then the -4 for 0.0204. And then 0.0272 in that. So iron is very. I think it's not wrong, it's just about it. I got 6 decimal points on what you take away. We just round
Okay, on this one. Oh, and one one's on 0.1. Because there's. So there's, yeah,
Yeah, now I'm telling you.
Yeah.
Okay, so. Did you get 0.0056?
You know, I feel
Yeah, I did that. So 0.0. So 0.
What would you?